Bismillahirrahmanirrahim. Let's go to the first title in our book and our preparation course, the polynomial. What do I mean by polynomial? I mean by polynomial any equation that consists of variables and constants. For example, 2x plus 3 is called a polynomial. If it's 2x squared plus 3x, it's also called a polynomial. If it's 2x squared plus 3x plus 5, it's also called polynomial. I can not add the 2 and 3 and 5 because they are not like terms. They are not like terms. Into this class, we are going to study how we can add, subtract, divide, and multiply the polynomial. We are using the polynomial in all kinds of questions that we are solving. Later, we are going to classify the polynomial into first degree or second degree or third degree into the equations and functions. First question here, it says add or subtract the like terms. And as we can notice that I have outside a positive sign. If I have outside a positive sign outside the bracket, all what I have to do to write down these two brackets again without changing the sign. So I didn't change the sign of 2x squared. I didn't change the sign of 1. Then I'm going to underline the common or the like terms. What do I mean by like terms? The one that have the same degree. Here I have 5x squared. There I have 2x squared. And I have here 3x and no terms have x. So 3x is no like terms in it. And I have -2 and +1. So I'm going to write that 5x squared plus 2x squared is 7x squared plus 3x, the yellow term. -2 and +1 give me negative. So if I have positive outside the bracket, all what I have to do is just expand the bracket without changing the sign. Regarding number 2, I have 3x minus 2, but I have negative outside the bracket. Negative outside the bracket will change the sign inside the bracket. So it's going to be -2x squared, and -2 times 1 is -1. Then I don't have for 3x and -2x any like terms. But regarding -2 and -1, I have like terms. So I got to add them up. So it's -2x squared plus 3x. If I don't have sign here, I added plus. And -2 minus 1 is -3. If you are watching this video, please pause the recording for 2 minutes and then try to solve question 3 and question 4 and then come back to correct it. It's very important to work during the class. First, again, I'm going to write 3x squared plus 2x minus 5, and then I have positive outside the class, the bracket, so I'm going to write it as 2x for 3 plus 5. Then -5 and +5 will give me 0. So, and 2x power 3 and 3x squared and 2x, there isn't any like terms in it. So I'm going to write it down as 2x power 3 plus 3x squared plus 2x. I prefer to be in a descending order of x. Okay. Now, for number 4, I have negative outside the bracket. So I'm going to write the first term as x squared minus 3x plus 2, and then change the sign inside the bracket. Notice that this is negative, become positive. This is positive, become negative, and this is positive, become negative. Then let's underline the like terms. I highlight it for you. -3x and -3x are like terms. +5 and +2 are like terms. So the final answer is going to be -1x squared, because +1 and -2 is -1. -6x after I'm adding them plus 7. Now, let's speak a little bit about the rules of exponents. If I'm multiplying x to the power of 2 and x to the power of 3, the answer is x to the power of 5. But if I'm dividing x power 5 by x power 2, the answer is x power 3. Notice that in SAT, we don't have this sign. We're writing x power 5 divided x power 2 like this. So this sign, same as division in the American stream or the SAT test. Number 3, very important rule. But let me add for you another rule here, number 3. If you have x power m and all to the power of n, it's x power mn. So I am multiplying the power. For example, x power 2, all power 3 is equal x power 6 and not x power 5. So 3 important rules while I'm multiplying the power of exponent, or I'm using the rules for exponent, that x power 2 times x power 3 is x power 5. X power 5 divided x power 2, I'm subtracting the power, but power to the power is multiplication. Now, it's very important to know how to expand bracket to the power of 2. If you don't know how to use this method, you can write it as x plus 2 multiply x plus 2. And I'm going to explain for you this by using the examples. So now we are moving to multiplying and dividing polynomial. In multiplying and dividing polynomial, multiplying we are adding the power, but in dividing we are subtracting the power. Question number 1, I have one term outside a bracket of 3 terms. So I'm going to multiply 3x by 2x squared and 3x by negative 3x and 3x by 5. 3 times 2 is 6. X power 1 times x power 2, I'm going to add the power, so it's going to be x power 3. 3 times negative 3 is negative 9. Positive multiply negative is give me negative. 9x to the power of 2. Why 2? Because here I have 1 and here I have 1. Then plus 3 by 5 is 15x. This is I multiply, or here I multiply one term by 3 terms. What about multiplying 2 terms by 2 terms? You have many methods in this. For me, I prefer if we can just draw an arrow for how we can multiply. X squared multiplied by 2x, then x squared multiply negative 5. Then I go back 2 multiply 2x and 2 multiply negative 5. X squared multiplied 2x is 2x power 3. X squared multiplied by negative 5 is negative 5x squared. 2 multiplied 2x is positive 4x. 2 multiplied by negative 5 is negative 10. Notice that I don't have any like terms here. So I'm not going to add anything. I keep the 4 terms here together. But in number 3, when I'm multiplying them, I will have like terms in the middle. 2x multiply 3x, then 2x multiplied by negative 2. 3 multiply 3x and 3 multiplied by negative 2x multiply 3x, 6x squared. 2x multiplied by negative 2 is negative 4x. 3 multiply 3x is 9x, and 3 multiplied by negative 2 is negative 6. Notice that I have here like terms. So I'm going to put down 6x squared. I'm going to put down negative 6. And then I'm going to add the 2 like terms, positive 9 and negative 4. I think all of you know that negative 4 and positive 9 is positive 5x. So usually the expand of 2 terms usually give me 3 terms in descending order, x power 2, x power 1, and then the absolute value without values, without x. Regarding number 4, notice that it's the same terms, but the sign here, one of the brackets is positive and the other one is negative. So put in your mind that this is the only case that when you multiply it will give you 2 terms. And this is, we call it difference of 2 squares. X squared minus y squared is equal x minus y multiplied by x plus y. So 2x multiplied 2x is 4x squared. 2x multiplied by negative 4 is negative 8x. Positive 4 by 2 is positive 8x. And then positive 4 times negative 4 is negative 16. So we are going to cancel these two because it's positive and negative. So it's 4x squared minus 16. So notice that we have two kind of questions. The one that different, it gave me 3 terms. The one that have the same sign, same terms but different sign in the middle, one is positive and one is negative, it gave me 2 terms. Now, if I have number 5 and I have bracket to the power of 2, usually I don't like to use the method that the first square plus the second square multiplied the first by the second multiplied by 2. I prefer if you can write it as 2x plus 3 multiplied by 2x plus 3. Then 2x multiplied 2x is 4x squared. 2x multiplied by 3 is positive 6x. Positive 3 by 2 is positive 6x. Positive 3 by positive 3 is positive 9. So I'm going to add the like terms in the middle. So the final answer is 4x squared plus 12x plus 9. Notice that any bracket to the power of 2 should give 3 terms. Any bracket to the power of 2 should give 3 terms. Now I'm going to pause the video for 2 minutes and try to solve question 6 and question 7. Regarding 3x minus 5, I'm going to write it into 3x minus 5 and 3x minus 5. I'm not going to change the sign. It's negative, so both brackets are negative. 3x by 3x is 9x squared. 3x multiplied by negative 5 is negative 15x. Then negative 5 by 3 is negative 15x. Negative multiplied by negative is positive 25. Then here is the like terms. Means that I'm going to put down 9x squared. I'm going to put down the 25. And negative 15 as negative 15 is the double of negative 15, which is negative 30x. Question number 7. 2x squared multiplied by minus 5 all to the power of 2. So it's 2x squared minus 5 multiply 2x squared minus 5. First by first, first by second. Second by first, second by second. So 2 multiplied by 2 is 4. X squared multiplied by x squared, I'm going to add the power. So it's going to be x to the power of 4. Minus 2x squared multiplied by negative 5 is negative 10x squared. Negative 5 by 2 is negative 10x squared. Then negative by negative is positive 25. I have 2 like terms in the middle. So it's 4x to the power of 4 minus 20x to the power of 2 plus 25. Regarding question number 8 and number 9, you should notice something, that both of them have the same terms, x and x, 3 and 3, but the difference is the sign. So this is, as we said a few minutes ago, it's called difference of two squares. So all that I have to do to multiply the first by the first and the second by the second. So it's x squared minus. Regarding number 9, x multiplied by x and 5 multiplied by 5. So it's x squared minus 2, 5. And this is the only case that gives you 2 terms if it's a difference of 2 squares. Now, let's go to divide. Usually, the divide comes in the test like this. 15 x power 3 minus 25 x squared, sorry for that, plus 5x divided by 5x. So, I'm going to divide each term by 5x. I'm going to divide 15x power 3. I'm going to divide negative 25x squared. And I'm going to divide positive 5x. So 15 divided by 5 is 3x squared minus 25 divided by 5 is 5. and subtracting the power. This power is 2, this power is 1, I'm subtracting the power. Plus 5x divided 5x, any term divided itself is 1. So 3x squared minus 5 plus 1. I'm going to rewrite it as 8x to the power of 5 plus 4x power 3 minus 2x squared divided by 2x squared. 8 divided by 2 is 4. X power 5 but x squared is x power 3 after subtracting the power. Positive 2 divided by positive 2 is positive. 4 divided by 2 is 2. And x to the power of 1 after subtracting the power. Minus, it's the same terms, so it gives me 1 and not x. Now, let me introduce for you some words or expressions in algebra that we are going to use while we are solving the SAT questions, or generally while we are solving any math problem. The word add is the same as the word sum, and it means plus. The word add is the same as the word sum, and it means adding two numbers, x and y. Number increased by 5 and 5 more than, so more than and increased by, both of them means addition. You can write it as x plus 5 and 5 plus x, and this is called commutative property. But subtract from, it's very important to understand that what after from came first. What after from came first. Subtract x from y, so it's y minus x. Subtract 5 from 3, it's 3 minus 5 and not 5 minus 3. Difference between, it could be x minus y or y minus x, because I'm looking for the difference. What is the difference between 3 and 5? It's 2. What the difference between 5 and 3 is 2. But subtract from, what after from should come first. It's have the same meaning, difference as how much greater y than x. So it's x minus y. How much greater than y is x. So it's x minus y. Less than, it means also minus, and 5 less than a number, if we assume that the number is x, so x minus 5. The word product, the same as multiply. Product is the answer of the multiplication. We call it product. So product, the same as multiply. So x times y or y times x, it's a commutative property. So xy. So product, the same as multiply. Quotient is the answer of division. Divide x and y, or sorry, divide x by y, so it's x divided y. And we can rewrite it as x over y. So quotient, the same as divide. Finally, square of a number is x squared, but square root is root of x. Cube root is the cubic root of x. This is how we change from algebraic words to algebraic expressions using the division or multiplication, addition, or subtraction. Now, we have some operations on the fractions. If I'm going to add two fractions with the same denominator, I'm going to add the numerator, like 2 over 7 plus 3 over 7. I put down the denominator, then I add 2 and 3, gives me 5. But if I have different denominator, I multiply the denominator, then I cross a by d and b by c. Let me give you an example for this. Number 1, 3 over x plus 2 over y. So I'm going to multiply x and y. Then I'm going to multiply y by 3, 3y. Add this side, and 2 by x is 2x. So it's 3y plus 2x divided by xy. Another solution that you can write it as 3 over x plus 2 over y. Multiply 3 by y and write it up. Multiply 2 by x and write it up. And multiply down. This is, we call it the butterfly one. So here is xy, here is 3y plus 2x. Same method, solving question number 2. I'm going to multiply x by x plus 1. X multiply x plus 1. And multiply 3 by x. Add down the sign. And 2 multiply x plus 1. Let's go to simplify. So it's x multiply x plus 1. And usually we don't expand the bracket in the denominator. Up 3x. Negative 2 by x is negative 2x. And negative 2 by 1 is negative 2. Add the like terms. So it's x minus 2 divided x multiply x plus 1. If I have a whole number plus a fraction, I can change the whole number, which is 1, especially 1, to be written as x plus 3 over x plus 3. Why? Because the denominator here is x plus 3. So I'm going to write it as x plus 3 plus x plus 3. And the second one is 2 over x plus 3. Again, 1 can be written as f for x. Y over y. 7 over 7. I can rewrite the 1 as any fraction, have the same numerator and denominator. Now, I have the same denominator. I add it down. I don't multiply it. And x plus 3 plus 2. So it's x plus 5 divided x plus 3. This is the simplest form of it. How we can multiplying and dividing two algebraic fractions. How we can add and multiplying two algebraic fractions. A over b multiply c over d is equal ac over bd. So all what I have to do is to multiply up and multiply down. For example, 2 over 3 multiply x over y. Notice this is considered as multiplication. So 2 by x and 3 by y. The second one, if you have division, we don't have division in fraction. We change the division into multiplication, but we find the reciprocal of the second term. If it's c over d, we flip it to d over c. If it's c over d, we flip it to d over c. For example, 2 over 3 divided by xy. So I'm going to keep the 2 over 3, change the division into multiplication, flip the fraction, so it's y over x. So it's 2y divided by 3x. Let's go to solve some examples. Number 1, x multiply 4y squared divided by 2y multiply 3z. 1 multiplied by 4 is 4x y squared. 2 multiplied by 3 is 6y z. Notice that this is y squared and this is y to the power 1. I can simplify them. So it's 4xy divided by 6z after subtracting the power. So simplify is very important step regarding your solving. Number 2, it's 6 multiply x plus 5. And down 2 multiply x minus 3 multiplied by x plus 5 squared. Here I have power 2 and here I have power 1. If I can cancel x plus 5 as a bracket is 1 of the x plus 5 down, and also simplify the 6 divided by 2, it's a division operation, can be rewrite as 6 divided by 2 is 3, 2 is finished, so x minus 3 multiply x plus 5. Mr. Hisham, I keep it like this. Yes, you can keep it like this without expand the bracket in the denominator. Regarding number 3, I'm going to change the sign of division into multiplication and flip the fraction. So it's going to be 12x squared divided by 25, and here 5 divided by 3x. You have one of two solutions. You can simplify before you multiply, or you can simplify after multiplication. What do I mean? I can multiply them. So 5 multiplied 12 is 60. X squared divided by 75. 3 multiplied 25x. Then I divide it up by 15, gives me 4. I divide it down by 15, gives me 5. And x squared divided by x power 1, subtracting the power, so it's 4x over 5. Or, let me change the color, I can write it as 5 divided by 3x multiplied 12x squared divided by 25. Divided by 3 here gives me 1. Divided by 3 there gives me 4. Divided by 5 gives me 1. Divided by 5 gives me 5. So directly, and divided x by x and x by 1. So down 5 and up 4x. So I can multiply, then simplify, or I can simplify, then multiply. Question number 4, if I have this sign, I can rewrite it as x plus 1 over 15 divided x squared minus 1 over 25. Then change this sign into multiplication, flip the fraction, and after flipping, I'm going to write x squared minus 1 as x minus 1 times x plus 1. Difference of two squares. Here, x plus 1 divided 15. Divided by 5 gives me 3. Divided by 5 gives me 5. Cancel x plus 1 with 1x plus 1. So it's 5 and down 3 multiply x minus 1. My advice to you is to rewrite these questions. Pause the video, try to solve it by yourself, and then come back and check your answer. Bismillahirrahmanirrahim. Let me introduce for you how we are solving. Let me introduce for you how we are solving the questions in SAT. Okay, it's a little bit different, and I'm going to show you one of the methods that I'm working with. For the first question here, it says, what is the sum? Sum, I know that this is addition between these 3 terms and these 4 terms. As I notice that the last term here is negative, the first term of the second expression of polynomial is negative 11. So, and I don't have any like terms with absolute value. So the final answer should be negative 11. Or I can say that negative 11 and no like term, the answer cannot be A, cannot be D, cannot be C. Again, this is how I'm solving SAT. Yes, in some particular questions. Of course, not all the questions in SAT you can solve it like this. But the easy level of questions in SAT, you can solve it like this. Because you need to save time to the rest of the questions or the difficult one. What is the simplest form for number 3? What is the simplest form of x minus y minus c? We know that when you expand negative, you are going to change the sign. So it's negative y, and negative by negative is positive c. So first, I'm going to cancel b, I'm going to cancel d. Why? Because c is negative. And I put in my mind that the answer is one of 2 things. It's going to be A or C. And instead of my choices is 4 choices, I can decrease it to the 2 choices. So the percent of success is going to be 50% for each one of them. So one of the methods that you cancel one of the 2 choices, that you are sure that the answer is not going to be one of them. Here I have x minus y. Look, I have x minus y. So in number 1, I don't have to add all of the terms, but if I wanted to make sure, here 3 plus 2 give me 5, and I used one of the terms. This is difficulty level 1, easy, that you should solve it like this. The same as number 3. So one of the method that you cancel 2 choices that you are sure that it's not going to be the right answer. Another example, question number 2 and question number 4. What is the result of when 4x power 3 plus 2x squared minus 6 subtracted from? What after subtracted from come first? So it's negative 3x squared minus x plus 2 minus 4x power 3 plus 2x squared minus 6. Then I'm going to rewrite it as we learned it before, and change the sign of this bracket. So it's going to be negative, and negative by negative is going to be positive. Look here, positive 6 and positive 2 give me positive 8. And the only answer that have positive 8 is A. So sometimes when I'm solving the SAT, I need to write or rewrite only 2 steps of working. And then I will check the answers. Again, all what I have to do is to do 1 or 2 steps of working. I don't have to simplify all of this. I don't have to say that negative 3x squared with negative 2's give me negative 5x squared. I put down negative 4x over 3 and negative x. I'm going to put it down. No, only from the last term I can figure out the answer. Product means multiply. So I'm going to multiply 5x plus 2 and negative x plus 8. 5x by negative x is negative 5x squared. So I'm going to cancel it. Why? Because the first term is 5x squared, not negative. Then 5x times 8 is 40x. 2 by negative x is negative 2x. Positive 2 by positive 8 is positive 16. So I'm going to cancel D because the last term is negative 16. Positive 40 and negative 2 give me positive 38. Right? So I think I have. So positive 38x, as we can see that the right answer is A. Sometimes while we are solving the SAT questions, we need to think before we start working. And this is a big proof for that. If you start multiplying 4a by 4b and 4a by 2b and 4a by negative b, you will be far away from the answer. But if you look carefully at the first bracket, you will find that you can add the two terms 4a and 1a. Gives you 5 minus 3. And then 4b minus 2b minus b can be written as 4 minus 2 is 1, as 2 minus 1 is 1. So it can be written as 1b. So it's only two terms multiplied by one term. 5a multiplied b is 5ab minus 3 by b is 3b. So the final answer is D. So sometimes we need to think about solving the question before we start solving the question. Question number 7, it says that T is greater than W. How much greater is the sum of S and T than the sum of S and W? We know that T is greater than W. If we add S to the left and we add S to the right, it's going to be the same. T greater than W. So the question is, how much greater is T than W? How much greater is T than W? The difference between any two numbers is T minus W. How much greater 5 is than 3? It's 5 minus 3. How much greater my age than your age? Is my age minus your age. Another example, number 6, which is a very easy one. Which of the following is an expression for 10 less than? What is after less than come first? Product of x and y. Product means multiply. So x times y less than is minus 10. So the answer is D. Now, question number 8. What is the value of the product minus this product? So first, I'm going to separate the product. This is a free response question. 2x by x is 2x squared. 2x by positive 6 is positive 12x. 3 by x and 3 by 6. Then 2x by x is 2x squared. 2x by 10 is positive 20x. Negative 5x and negative 50. So by adding the like terms here, it's 2x squared plus 15x plus 18 minus 20 minus 5 is 15, but I'm going to multiply by negative. So negative 2x squared, negative 15x plus 50. Negative 15, negative 2x. So the remainder is positive 18 and positive 50, which is 68. I'm going to speak later about how we can shade the answer into the grid section of section 3 and 4. Question number 9. If x, y, and z are positive numbers, and the sum of x and y, let's stop here. Sum of x and y, so x plus y, is equal to the square of z. Which of the following is equal to z? By taking the root for both terms, z will be equal to the root of some x and y. So the answer is B and not A. The answer is B and not A. Okay? Okay. Now let's go to the comparison or the equivalent questions. And this kind of question is very important because it came more than one time into the SAT questions. Px plus q to the power of 2 is equal 9x squared plus kx plus 16. So I gotta expand bx plus q and px plus q and compare the answer with the answer given. Px by bx is p square x squared. Px by q is pqx. Q by px is pqx plus q squared. So it's b squared x squared plus 2pqx plus q squared. Let's compare about with this one with the one given, 9x squared plus kx plus 16. So q squared is equal to 16 and p squared is equal to 9. So it's clear that p is equal to 3 and q is equal to 4. And by the way, if you are smart enough or you know how to expand the bracket, you know that p squared give you 9. So directly p is equal to 3. Q squared is equal to 16. So q is equal to 4. But I tried to expand it for you just to explain it. And k is equal to pq. So 2 multiply 3 multiply by 4, which is equal to 24. So the right answer is D. So sometimes I need to write more than one steps while I'm working with the SAT. Let's go to question 10. In the given figure, what is the length? Here is A to B, B to C, C to D. What is the length from A to D? All what I have to do is to add x plus 3 is 2x minus 1 and 7. 2x and x, 3x, positive 3 and 7 is 10, minus 1 is positive 9. So the right answer is D. Again, number 12, equivalent or comparison between two polynomials. X squared plus bx plus b is equal to x minus 9 times x plus 9. So x squared plus ax plus b is equal. This is difference of two squares. Give me x by x and negative 81. So it's very important to understand when you multiply two terms gives you 3, or when you multiply two terms gives you 2. As we notice or compare the left with the right, x squared, here is I have x squared. Positive b, I have negative 81. But for ax, I don't have any term that in ax in the other side. This one, I don't have the same on the other side. So I may cancel it. So by comparing these two terms, x squared plus b is equal to x squared minus 81. So a is equal to 0 because there isn't any term here, and b is equal to negative 81. By multiplying a and b, 0 multiply anything is equal to 0. So the product of AB is equal to 0. Regarding question number 30, for what value of p is x minus 2 times x plus 2 is equal to x times x minus 2? I can notice that I need to simplify the left-hand side to be written as x squared minus 4x. And to expand the right-hand side, x by x is x squared minus x by p is x. So x squared, x squared. So we can notice that negative 4x is equal to negative xp. So negative 4x equal negative xp. If I cancel negative x with negative x, so p is equal to what? P is equal to 4. I did a mistake. What is my mistake? My mistake that in difference of two squares, I wrote it as negative 4x. And this is a common mistake. I did it on purpose. Most of the students do it. So this is wrong at all. And the students choose the answer is B is negative. When I expand x by x, it gives me x squared minus 4 without x. Without x is equal to x squared minus xp. So xp is equal to 4. xp is equal to 4. So what the value of p? It's 4 divided by x. I figure out p in terms of x. So sometimes the letter or the coefficient you are looking for, it may be in terms of another number. Let's go to question number 15. If n is greater than 0, and I mean by n greater than 0, it's a positive value. For 4x squared plus kx plus 25 is equal to 2x plus n squared. Let's expand this. 2x plus n multiply 2x plus n. So 2x by 2x is 4x squared. 2x by n is 2xn. n by 2x is 2xn. Plus n by n is n squared. So this one can be written as 4x squared, adding two like terms, 4xn plus n squared. Let's compare between this one and that one. 4x squared plus kx plus 25. So it's clear for us that n squared is equal to 25. I'm supposed to say that n is equal positive and root of 25, but I'm going to take only the positive value. So n is 5. And 4n is equal to k. So k is equal 4 by 5, which is equal to 20. He is looking for k plus n, so 20 plus 5 is equal to 25. My advice to you is to pause the video at the beginning of this question and to solve it by yourself, and then to check the answers once and twice. Question number 14. X squared plus kx plus 7 is equivalent to that. All the students know that when I multiply 1 by h, it gives me the last term. So let's be smart. 1 by 8, don't work hard, but work smart. 1 by h give me 7. So it's clear for us, this is x plus 1 times x plus 7, as h is equal to 7. He is looking for k. So let's expand x by x, x squared, x by 7, 1 by x, 1 by 7. So the middle term is 8x. So the value of k is equal to 8. Regarding question 16, it's the same. I'm going to compare between what's written on the left with what's written on the right. So I'm going by expand. 2x by 3x, 6x squared, and 2x by 5 is 10x. Then 3 by 3 is 9x, 3 by 5 is 50. Adding the like terms, 9 and 10 is 19. Compare this one with ax squared plus bx plus c. So it's clear that a is equal to 6, and b is equal to 19, and c is equal to 15. He's just only looking for the value of b. Notice that some questions he may ask about the value of a times b times c, or the value of a squared or b squared or b minus c. So I explained for you that a is 6, b is 19, and c is 15. Target was to find the value of. Another question. Here, I'm going to solve this one by not by using the expand. Okay, so listen carefully and look carefully how I'm going to solve this one. I'm not going to look for the value of a, so I'm not looking for the x bar. I'm not looking for the value of b, so I'm not looking for x squared. I'm looking for the value of c, which represents the x. So I'm going only to multiply the brackets or the terms that give me x. If I multiply 3x squared by 3x, it will give me x power 3. I don't need it. If I multiply 3x squared by 6, it will give me x squared. So I don't need this term. If I multiply 4x by 3x, give me x squared. I don't need it. If I multiply 4x by 6, give me 24x. Plus, if I multiply 5 by 3, give me 15x. And I don't have to multiply 5 by 6. Why? Because 5 by 6 is 30. And I'm not looking for A or B or D. I'm looking for C, coefficient of x. By adding these two, it's going to be 39x. So the value of C is equal to 39. So the difference between this one and the one that we solved it, number 16, that I don't have to expand the whole terms. I don't have to expand the whole terms. Let's go to question 19. If a squared plus b squared is equal to 4 and a minus b squared is equal to 2, what the value of the product? This one is difficult. First, I need to expand this. A minus b multiply a minus b. It gives a by a minus b, a minus b, and positive b squared. So it's going to be written as x squared minus 2ab plus b squared. It says that this bracket is equal to 2, so it's equal to 2. And it says that a squared plus b squared is equal to 4. So I will move a squared and b squared and write 4. So negative 2ab plus 4 is equal to 2. By moving positive 2 to the other side, so negative 2ab is equal to 2 minus 4, negative 2. By dividing by negative 2, so ab is equal to 1. So what he is looking for is equal to 1. As we can see, while we are solving this question, we wrote 1, 2, 3, 4, 5 steps. So sometimes if the question is from the third difficulty in SAT, you may write all the kind of steps and working. Notice the difference between question 17 and question 19. Question 18.
Mr. I have a question.
Regarding question number 18, if ax plus 2 multiplied by bx plus 7 is equal to the following. As we noticed, 2 by 7 is give me 14. Let's expand it. Ax plus 2 multiply bx plus 7. So ax by bx is abx squared. And 7ax. And 2bx. And 14. If I compare between the product of AB and x squared, I will figure out that AB is equal to 15. So two numbers, their product is equal to 15. And it says here that these two numbers, their sum is 8. So two numbers, the product is 15, 1 by 15, or 3 by 5. So I can assume that A is 3 and B is 5. If I replace here A with 3, this term will be 7 by 3, 21x. And if I replace B with 5, 2 by 5, it's going to be 10x. Their sum is 31x. So C, one of the answer is 31. And as we can see, the only answer that have 31 is D. What if you wanted to figure out the second value? I assume that A is 3 and B is 5. You can assume that A is 5 and B is 3. In this case, we'll give you that A, B, their sum is 41, but you don't have to solve all the kind of the steps for it. Again, I expand the bracket, I compare between the value of A and B, I figure out the value of C. This question passes through all kind of polynomial operation we have studied. Regarding the last one, as we can see, I have bracket to the power of 2. So I'm going to expand 1 over A plus A and 1 over A plus A. 1 over A times 1 over A is 1 over A squared. Plus 1 over A multiplied by A is 1. When you multiply 1 over 3 by 3, it gives you 1. When you multiply 1 over A by A, it gives you 1. Plus A, multiply 1 over A, 1. Plus A by A is A squared. It says that all of this is equal to 100. So 1 over A squared plus 2 plus A squared plus 2 is equal to 100. By moving to the other side or subtract 2 from both sides, 1 over a squared plus a squared is equal to 98. In this kind of questions, it's very difficult to figure out one value and you add it to its reciprocal to give you what? To give you 100 and square to give you 100.